It's STEAM time! Welcome back to the Maker STEAM Club with STEAM host. I'm Godiva. Let's make something together.
Hi makers, welcome back to the Maker STEAM Club. This week, we're going to be stepping things up a notch. We've so far done series circuits, parallel circuits, we've talked about PCBs, soldering, but what happens when you put everything together? We're going to be finding out by making a simple toy, a little ABC, using some components that you've already learned about and some fun images that we like to see in everyday life. Now, let's get started. Have you ever heard of a busy board? Maybe you've seen those small toys that 3-year-olds, 2-year-olds play with that has light and sound on it. So we know a little bit about light and sound. So it's time for us to build a simple ABC toy that will light up whenever we press a button and also give off a sound. Here's what we have to get this project done. We have our craft board, we have our PCB, we have some images, a bit of wire, and the components that we'd have used in our last set of circuits. Let's start putting this all together. Now that it's time for an enclosure, we have to first start by measuring and marking our craft board. We'd have done some of that work here already. So if you'll notice, we have one piece that will be our face that is 10 inches by 5 inches. We're going to use a face panel as well as a back panel that's just around the same size. We'll also need 2 pieces for the top and bottom. Each of these are going to be 2 inches by 10 inches. And last but not least, for the sides, we're going to need 2 pieces that are 2 inches by 4 3/4 inch. Now that we have our 6 pieces, you'll realize that for the front panel, we actually had a circle, triangle, and a square. This is where we would have cut out to put pictures of the images that we're going to be using in our ABC toy. So we're going to be starting off by making a simple box. This will be the back, and we have cardboard cut from craft board to basically have the sides and the top and bottom. To make it fun, we've actually gone ahead and taken the face of our toy and cut out a circle, a triangle, and a square. Because we've been so in love with RGB colors, for this we're actually going to be placing red cellophane behind our circle, green behind our triangle, and blue behind our square. Now let's get started putting together our box. So we have to ensure that the glue gun is actually heated up properly, but once it is, we can start going. Don't let me down, glue gun. Maker's gonna make, potatoes gonna potato, and steam makers make the best makes. Ready for our next side. Potatoes gonna potato, maker's gonna make, and if you're a potato maker, you make potato. So 3 sides down and 3 to go. So now that we're making our ABC toy, we're going to need 6 sides. So we have our face panel and our back panel, both the same sizes. And then we have our side panels as well as the top and bottom of our enclosure. All of these put together are going to give us a 6-sided object. We've marked out our circle, triangle, and square. Now it's time to mark out the holes for actual buttons of our toys. So we've actually printed 3 of these. It's really kind of cool because we have on the bottom these flanges that are actually going to be able to press down on our tactile switches. Now let's draw them out. Now we have our 3 buttonholes for each of our images. Next up, we want this to look really nice. So we're going to be taking this front panel here and putting a bit of cellophane behind each of our shapes. I've said cellophane quite a few times, and you're probably wondering, what is cellophane? Ever seen those plastic folders with the transparent covers? That's exactly what we're cutting from. We have 3 panels in green, red, and blue, and what we're going to be doing now is cutting 3 squares that we'll put at the back of each of our shapes. Now that we have our 3 pieces of cellophane, let's go! So we have our red, our green, and our blue cellophane. Now we're going to flip over our face and hot glue these on. So we have our panes cut out, and now it's time to measure them out on our craft board and actually start to glue them down. So we started off with red, then we go to green, and lastly there's blue. Let's go. Let's work on a triangle. And we tend to be using this because this will allow the light to be diffused easily. Alright, there we have it. Red, green, blue. So we just finished up gluing our cellophane onto our craft board. So if we flip over, we do have our red, green, and blue. And because this is an ABC toy, we are actually going to be having images that represent A, B, and C. So here they are. A for aunt, B for bread, sliced bread, and C for car. Now let's get cutting. So we've gone ahead and actually cut out our images. We have our bread in the middle, our car. We've cut out the holes for each of our buttons. And now we have one last piece left to glue. And that's Auntie! Let's go. There we have it. A for aunt, B for bread, and C for car. Let's see if our buttons fit, by the way. We have our buttons in. So here's an additional step just to ensure that our buttons are secured to our craft board. We're going to go ahead and take our hot glue gun and go and put our glue around the buttonhole and stick our buttons in right there. And for our last button, we're going to secure it by putting hot glue around it and pushing it through our holes. So there we have it, the face of our ABC toy. We have to press each of our buttons to let everything light up. Now we have our pictures glued to our craft board, glued to our cellophane with our buttons in. Now it's time to assemble our circuit. Last week, we did our sound and light circuit on one PCB. This time around, we'll use several PCBs to assemble several circuits that will all go into our ABC toy. Here we have our 3 PCBs. And on each of these PCBs, we'll be soldering one resistor as well as one tactile switch in the center of the board. Here we have our 10 ohm resistor, and now just adding our tactile switch. Now let's get soldering. And we're done. So there we have it, our 3 PCBs, each with a resistor and a tactile switch. Now, to ensure that the light diffuses well in our ABC toy, we're actually going to be using 3 LEDs for each color. So we have 3 red LEDs that we'll be connecting in series. But before we get that far, we want to ensure that these are positioned correctly on our craft board. So let's just go ahead and hot glue or 3 red LEDs. Before we go ahead and start to glue these LEDs onto our craft board, we have to actually connect them. So remember, we connect positive to negative to positive to negative. Let's go! We have our longer lead here, which will be soldering to our negative or shorter lead on our next LED. Now that we're going to be connecting our 3 LEDs right onto our craft board, we want to ensure that they're connected through some wires. So we've got 3 pieces of wires, all in red colors, and we're going to be starting off by taking our positive lead here, running through, taking our negative lead of this LED to the positive lead of the next, and then the negative lead here goes to the positive lead of the next, and then the negative lead here will be going right back to our PCBs where everything is being powered. So let me show you what happens next. So here we have our 3 LEDs connected that can be now glued on to our craft board. But this sort of reminds me of Christmas lights. Ever thought of it like that? If one light goes out in a string of Christmas lights, none of them tend to light up. And that's because they're often connected in a series circuit. Hopefully, none of our lights ever go out, and we'll continuously be able to have 3 lights on for our red side of our ABC toy. As we go ahead and glue our red LEDs to our craft board, you'll realize that we have our black wire, and black, as we already know, is for ground. So always we should be able to pay attention to our negative and positive side, or what we call power and ground. Red typically tends to be positive or power, and black or blue is ground or negative. Now that we've done this for our red LED, we'll do the same for our green and blue. So far, we've done so much work. We've gone ahead, built our face, placed our icons on, and we did a little bit further with our PCBs. So we have 2 PCBs in already, and we're going to complete the last one together. You'd have seen where we put in our button, but now we've also 3D printed some braces. And these braces will be hot glued right beside our buttons so that we'll have support when our flanges touch the push button. And here we are, one brace in, and now we can hot glue our PCB. I went ahead and did the hard work of soldering the resistor to the positive lead of our red LED, which will have the electricity flow right through all 3. Now, I want to make sure that when I'm positioning my button over the flange, it pushes it directly, because we want to ensure that for this ABC toy, it's going to pop right up. So let me put some hot glue on our flanges, but first let me make sure it's actually dry. Test it out, test. Okay, we're good. This side is where we'll be gluing the rest of our LEDs. Here we are. So I want to make sure that the button is exactly over the flange. So it needs to be able to press all the way down. Perfect. So just give that a second. And now I can put the other 3 LEDs down on the cellophane. Yeah. Do you see that pop? Yeah. That's what we want. Alright, so let's get the first LED. And remember, we're using 3 LEDs instead of 1 so that we can increase the brightness. So there we have it, all 3 LEDs in place. So we have the red ones, the green ones, the blue ones, and then we have all 3 of these leads. Now, because of how we had set out our circuit diagram, yes, the circuit diagram, how this will work is that we're going to take power from our battery pack. It will go through these switches, and each of these wires here will be connected to our switch. So we're going to save ourselves the trouble of trying to solder these wires, and we are going to use something called heat shrink tubing. So here we have our heat shrink tubing, and this we sort of use to ensure that we can have neater circuits. And the good thing about it, it's insulated, so our wires don't end up touching each other and having the electricity go where we don't want it to go. Now, the first lead from our battery pack, and we're going to use this wire cutter to strip our wire down just a little bit. So we want to give it more room to actually twist all these wires onto each other. So we're stripping our wire that comes from our battery pack. So these wires are a little difficult because they're multi-strap and we don't have a wire stripper. This is actually a cutter. All right, so there we are. Now, again, all of these 3 wires from our PCBs will connect to a switch. From the switch, it's connected to a resistor. From the resistor, which lands just around here, we're connected to 3 LEDs in parallel. And now we can take our heat shrink tubing that we've twisted the wires, we can take our heat shrink tubing and push it all over all 3, just like that. Now, this is not the neatest way to do it, but we're makers. We do imperfect things. I'm going to be taking the tip of the hot glue gun to go ahead and actually shrink the heat shrink tubing. You can often use a blow dryer at home, or maybe you can use a lighter, or you can use a heat gun. So all of these would be pretty useful, just ensuring that you can shrink your heat shrink tubing. So you'll notice the heat shrink tubing, when you put heat on it, it actually shrinks. But be careful when you're using hot objects. You don't want to burn yourself either. Okay. Perfect. But I want to make sure that, this actually works. So I'm going to do a little test. So as makers, one of the things that we should learn to do is troubleshoot all throughout. So I'm going to turn on this battery pack, and I'm going to test to see if these lights are actually working. Now remember, here's how the electricity is flowing through the circuit. From the positive side of our battery pack, it will be going through switches, 3 switches in parallel, then to a resistor, then to 3 LEDs that are also in parallel. So that means if I connect the negative lead of the LED to the negative lead or negative side of the battery, these 3 should light up, these 3 should light up, and these 3 should light up. Let me see. And there we have it. Alright, we're not quite there. Oh, but remember, we have switches in. So, there we are. For a second, we had an open circuit. Because we have switches in this circuit, we need to actually push down on the switch in order to close the circuit. So here we are, pushing down on the blue LEDs. Alright, we're testing. That one works just fine. Perfect. Now let's test the green ones. We're just gonna be holding it together. Ooh, something is happening with our... Ooh, the green ones are so bright. So the green ones are working when we press our switch. Switch is a little off. So we have to press in a very special place. Alright, there we are. You have to press on the top. Okay, perfect. So the green ones work. Now let's see if the blue ones work. Not blue, red. Perfect! So we tested all our LEDs, they're all working. But one of these green LEDs is starting to come off. So one of the things that you'll notice is that hot glue may not be the best thing to keep these in place. So maybe you want to try something else. Maybe you want to try super glue. Maybe you want to try having placeholders of their own so that they stay in place. Alright, so all of them are working, and now for just about the last component that we're adding to this circuit. So remember how electricity is flowing through this specific circuit. First, positive lead, then in parallel we have 3 switches, 3 resistors, and 3 LEDs, which means that now we have the negative lead of each of our LEDs. To this circuit, we'll be adding a buzzer, such that when you press the button, the light turns on and the buzzer goes off. Now, let us now take the positive lead of our buzzer, and we are going to connect it to the negative lead of all 3 of these parallel circuits with our LEDs. Again, remember, just like LEDs, buzzers here, they're also active components. So we have passive components and active components. And active components have both a positive and a negative side. Now, let's use our heat shrink tubing, and we're going to be connecting all 3 of these together. Something's wrong there. So it seems that our wires are a little too short to actually connect to our positive lead of our buzzer. So how can we fix this? Do we add more wires Or what can we really do? Let's put on our thinking caps a little. What do we have here? I think we could strip this one out. This is a black wire. It's a negative lead. So let's go ahead and connect this one. All right, makers, we figured out a non-ideal solution to a non-ideal situation. So what we're gonna do, we're gonna take this short black wire here and we're gonna start by connecting it to these two leads that are coming from our negative side of our LED. But first, we need to twist these ones off. Let's go ahead and take that. Now, we're going to take a bit of heat shrink tubing because we discovered that we can use that. And we're going to cut a small piece that we'll put over our black wire. Now, we can go ahead and twist these all together, or rather, make a small hook, making it easier for them to connect. So it seems it came off, so we may have to strip these down a little more. Strip that one down. Just want to have a bit more to work with. Oh, also, let's turn that off. Alright, we have a bit more wire available for us to twist. Okay, let's go ahead, put these two together. Just gonna put this hook on. So get our heat shrink tubing again. There we are. Just have all of these connected. Put our heat shrink tubing over it. So before we fully put in everything from our heat shrink tubing, again, want to make sure that this will actually work. So the idea is, if these two are connected, we should be able to run electricity through all of this all at once. Alright, so using our heat shrink tubing again, I'm gonna heat this up, shrink it down. We've extended our wire a little bit, so we can now have the positive lead of our active buzzer going to the negative lead of all three of our LEDs. So let's put all of these wires together, and we already put on a bit of heat shrink tubing, but we're actually going to make this a little smaller. So let's twist these together. Because these can be bent, it's so much easier if we just bend them. And now we've connected our buzzer. I think we could do this another way. Earlier we were planning on taking all three of these and connecting them to this one wire, but things have changed a little, so we're going to do this a little differently. We're going to take these two wires here, the positive lead of our buzzer, negative lead of our blue LEDs, and we're going to place it with the negative lead of the green and red LEDs. But first we have to put the heat shrink tubing on this side. Positive and negative leads connecting to our negative lead here, and twist. And then we can actually just go ahead and slide our heat shrink tubing over all three wires. We can take our glue gun and shrink our heat shrink tubing. We've been working really hard putting all of this together. If everything goes well, when we turn on our battery pack and we put these two wires together and press any of these switches, what's supposed to happen is that the lights as well as the buzzer is supposed to go off. Now let's see if that happens. All right, so let's test things out. Just gonna go ahead and take our negative lead of our active component and go right to the negative lead of our battery. There we are. Does the green one go off? Yes, it does. Hear that sound? Awesome. And the blue, let's just check where we are running with our blue wire. There it is. And so what I'm actually going to do is to rewire this, and the light will come on, and then we can call so the light will come on. All right, there is our blue on. Now that everything is working, we are going to go ahead and connect the last three wires. And we already have on a bit of heat shrink tubing, so it's just a matter of pulling that over these wires, and we'll use our hot glue gun to shrink our heat shrink tubing. So we have a bit of a bump here, squeezing, and take our time and pull our heat shrink tubing over this bump. So this is a very tight fit, so we don't even need to use our hot glue gun, but it's always good to shrink the heat shrink tubing anyway. Alrighty, here we are. So again, this one, perfect. And our last one, you'll realize that the blue one is a little dim, but we still hear that sound. This did come off, and we admitted earlier that hot glue maybe isn't the best thing to use. We want to think about using clips or more adhesive materials for whenever we're putting these components together. But because we're doing this for demonstrations, we don't mind having things be a little temporary. All right, so always remember we have to fit our button just over the flange. Perfect. We're almost there. We have everything working, LEDs, buzzers, switches, buttons. And now for the last bit, we need to put it all together. We had a box earlier, and we're gonna just start by painting our box. You would remember that we assembled this craft box, but you're wondering probably what we would be doing with everything. Let's see. I'm so happy that we are almost done. We finished painting our box, so now we just need to take all of our circuit and put it inside the box. We're gonna be gluing in our little battery pack on the side here so it doesn't move around in our box. Our battery pack is in. Just gonna be taking our buzzer, and we want it a little bit close to the surface. So we're gonna put it right on the side here. Get that loud buzzy sound. And now for the face. Yes. So this is a little more intense. Let's put everything in our box, put our wires in. So we're hiding it all away. And now we can go ahead and glue it in. And we have to move quickly because the hot glue is gonna dry. And there we have it. Our final package of our ABC toy. So we would have had Auntie. Love it. Then we have our bread. And then we have our car. Each of them lighting up. So there we have it, our ABC toy featuring our RGB circuit. So far, you've noticed we did LEDs, we talked about parallel circuits, series circuits, we talked about active components, passive components, and we introduced some passive components and active components of our own. By using something as simple as light and sound, we made ourselves a busy box. So let's try to see what can you make by knowing a little about simple circuits. Next week, we're going to go even further into circuits, and this time we're going to be building a Bluetooth speaker. So look out for that one.